The purpose was to apply knowledge of stoichiometry to a real reaction by determining grams and moles relationships between the reactants and the products. The basics of the reaction were as such. Copper was reacted with silver nitrate to produce silver and copper nitrate. Then, observing as copper ions join with nitrate ions forming a copper nitrate solution. The results of the reaction consisted of pure silver after the reaction had took place. Then all substances' masses were measured before and after the reaction. The theoretical yield was calculated through stoichiometry. Finally, percent error and percent yield were determined. Percent error for silver was 31%. The chemistry topics emphasized in this reaction were applying ideas from a single replacement reaction, calculating yields with stoichiometry, and determining the type of copper ions reacted. Some applicable vocabulary for this reaction may be a single replacement reaction, which is a reaction in which one element moves out of a compound and into another, which is a type of reaction in this test. Also, spectator ions, which are ions that do not gain or lose electrons, which was nitrate in this reaction. Oxidation is the loss of electrons, which was copper in this reaction. Reduction is the gain of electrons, which was silver in this reaction. This is all demonstrated by the unbalanced equation below. The problem of this reaction was to determine what type of copper ions were reacted. The hypothesis created was if the ratio of moles of silver to moles of copper is 2, then the copper ions were copper 2 ions, because the ratio of moles can show the coefficients in the balanced equation of the reaction, and the only way for it to be balanced is if it was copper 2 ions. This hypothesis was correct.
The materials are 1 6-inch piece of copper wire, about 15 milliliters of 0.10 molar silver nitrate, 1 250 milliliter beaker, 1 600 milliliter beaker, 1 digital scale, 1 glass test tube, parafilm, 1 pipette, 1 stirring rod, labeling tape, 1 distilled water wash bottle, acetone, a test tube rack, and a drying oven. Procedure for day 1. Obtain a 6-inch piece of copper wire and a clean dried test tube. Label the 250 milliliter beaker using the labeling tape with the period and table number. Find the combined mass of the copper wire and the labeled 250 milliliter beaker along with their separated masses. Create a coil shape by wrapping the coil wire around a pencil or pen. Lightly stretch the coil and place it in the test tube. Pour 15 milliliters of 0.10 molar silver nitrate into the test tube. Be cautious while pouring the solution because it will stain skin and clothes. Be sure that the solution fully covers the copper wire. Cover the test tube with parafilm. Observe and record the reaction that occurs for 30 minutes. Leave the reaction to continue for 24 hours. Procedure for day 2. Obtain a 600 milliliter beaker as your waste container. Shake the silver crystals from the copper wire using the stirring rod. Remove the wire from the test tube into a labeled 250 milliliter beaker. Rinse the wire using the wash bottle. Submerge the copper wire in acetone, then allow it to dry. Find the mass of the wire to the nearest 100th gram when it is dry. Use the pipette to decant the solution from the silver crystals into the first beaker. Use about 10 milliliters of distilled water to rinse the silver, carefully stirring with the rod. Let the silver settle, then decant the solution again. Repeat this 3 more times. Pour the liquid from the beaker into the waste bucket. The final solid should be in a 250 milliliter beaker. Place the 250 milliliter beaker in the drying oven after a final rinse. On day 3, find the mass of the dried silver metal to the nearest 100th gram.
The first observation is that the copper wire is shiny and the solution is clear and colorless. The explanation for this is the copper atoms are submerged in silver nitrate solution. Another observation is copper wire turns black in solution, and the explanation is that the copper atoms are being oxidized. The next observation is silver crystals are beginning to form on the surface of the wire, and the explanation for this is that the silver ions are reduced. The last observation is that the solution turns blue, and this indicates the presence of copper 2 ions, and nitrate is a spectator ion. The mass of the copper wire before the reaction was 1.14 grams. The mass of the empty labeled 250 milliliter beaker is 28.87 grams. The mass of the copper wire after the reaction was 1.08 grams. The mass of the beaker with the dry silver crystals is 29.01 grams. The mass of the silver crystals is 0.14 grams. The mass of the copper wire reacted or lost was 0.6 grams. The moles of copper reacted was 0.0009 moles. The mass of silver formed was 0.14 grams. The moles of silver formed was 0.0013 moles. The expected ratio of moles silver to moles copper is 2 moles of silver to 1 mole of copper. The experimental ratio of moles silver to moles copper is 1.6 moles of silver to 1 mole of copper. The amount of silver atoms is 7.8 times 10 to the 20th. The amount of copper atoms is 1.02 times 10 to the 22nd. The experimental ratio of atoms silver to atoms copper is 0.0074 atoms silver to 1 atom of copper. The percent yield of silver was 69%, and the percent error of silver was 31%.
The balanced equation for this reaction was copper plus 2 silver nitrate yields 2 silvers plus copper nitrate. Oxidation is the loss of electrons, which was copper in this reaction. Copper 2 oxidizes because it is in the reactants and it has a 0 charge and a positive 2 charge in the products. Reduction is the gain of electrons, which was silver. Silver was bonded to nitrate in the reactants having a positive 1 charge and was by itself in the products having no charge. Spectator ions are ions in the reactants and the products do not gain or lose electrons. This was nitrate because it was consistently the same as it was bonded to silver and copper in the products and the reactants.
The reaction ended up creating pure silver. The accumulation of multiple results proves that the hypothesis was correct. Since the ratio of moles of silver to moles of copper is 2, then the copper ion is in fact copper 2.
Percent of error was 31.2%.
The contributing factors that may have resulted in this percent error include not using clean glassware, not drying the silver enough, decanting too much silver from the solution, using tap water instead of purified water, and not using the correct scale of measurement during the experiment. This lab shows copper, silver, and nitrate reactions that occur in real life. This result can be made more accurate by repeating the same reaction a greater number of times to improve accuracy by reducing the percent of error.